guys. We are going to start with CP and CPK today. So I will quickly share my screen and we will do a little recap of the process and then we'll calculate CP and CPK today. All right, so my screen is visible to everyone, right?
Yes, Nayan.
All right, thank you. Okay, so CP. What is the full form of CP? If anyone remembers it from yesterday.
Process capability.
Wonderful. So CP is the process capability index, right? So basically, CP is a way to measure the potential capability of a process. All right. So our formula is very simple. How it goes? It is upper specification limit minus lower specification limit divided by 6 standard deviation. Now here this sign represents the process standard deviation. All right. So what does this really tells us? So basically CP compares two things. First, the width of your process spread. So this is your process and this is the spread. So it compares the process spread, which is also the 6 standard deviations. So the width of the with this width of the specification limits, which is upper specification limit minus lower specification limit. All right. Now, if CP is more than 1, it means that the process variation is narrower than the specification range. So the process has the potential to meet the requirements. We saw the example of car for that. Yes. Now, if CP is smaller than 1, the process spread is wider than the allowable limits, which means that the process cannot consistently meet the specifications. Now, but here's the catch. So CP looks only at the spread of the data, right? I told you this yesterday also that it only looks at the spread of the data. It does not tell us whether the process average is sitting in the middle of the specification limits or off to any of the sides, right? It doesn't tell you that process is centered or not. Now, for this, we took example of that box on the wall. Now, the specification limits are like a box that defines whether your product measurement, where your product measurement must be. So, your process output naturally varies, sometimes slightly above, sometimes slightly below the target. What CP checks, that is that variation small enough to fit inside the box. Okay. Now, if the variation is narrower than in the box, if the variation is narrower than the box, so CP will be larger than 1, which means that the potential capability is good. Now, if the variation is wider than the box, so CP is going to be less than 1, which means that process is not capable. You now understand how to calculate CP and how the result of CP will help us in interpreting the outcome. Now, let's understand few important things here. That high CP means variation small compared to the specification limit, which means that process has potential. Now, low CP means the variation is large, so they are going on contradictory side. So improvements are needed here. So remember this, okay? Now, also one more last thing I'm repeating again that CP does not check whether your process is centered or not. For that, For that, what are we going to do? Which term helps us in getting whether the process is centered or not? We covered this yesterday. Come on, quickly type in the chat box. If CP helps us in getting the process capability, which thing helps us getting whether the process is centered or not? What is that
CPK.
term?
CPK.
CPK. Great, great. All right. Good. Now we'll quickly do recap of CPK also, and then we'll move to calculating CP and CPK. So what is CPK? CPK is Process Capability Performance Index. Okay. Now, CPK not only measures the spread of a process, but also considers whether the process is properly centered, right? So within the specification limits. So let's see how the formula goes. Distance from mean to the nearest specification limit and divided by distance from mean to process edge. And that is why here it is written as MIN, which means minimum of this or this. So we'll calculate both the things, and the minimum value of it will be considered as the CPK. Okay, now here X bar is the process mean and this is the standard deviation. Okay, now while CP looks only at how wide the process is, CPK tells us whether the process is hitting the target in the middle of the specification limits or not. So essentially, it takes the smaller distance from the process mean to either LSL or USL, right? Okay. Now, if the process mean is perfectly standard, so the CP and CPK both will be equal. But if the process mean is shifted towards any of the limit, then CPK will be smaller than CP. And also, I got a question yesterday that what if CPK is greater than CP? Can anyone tell me, is it possible or not that CPK is greater than CP?
It's not
Is it
possible.
possible? No, it's not possible. Correct.
Yeah.
Now, so we have completed what is CP and CPK. Now let's see how. Okay, so we covered this also yesterday. Okay. Now, let's open your Excel sheets as we are going to do this exercise together. And I'm going to tell you, and you will calculate CPK and CP and CPK for this data. All right. So, ready when you are, tell me. So, the question is, they've already given you mean here. Mean of this process is 35.5. Standard deviation is 0.9. Specifications are 35 plus minus 3. For calculating CP, we have got a formula which is upper specification limit minus lower specification limit divided by 6 times the standard deviation. Okay, so let's start with CP first. So I will keep the screen here if you want. All right, so I'll keep the screen here and I'll guide you, and you guys open your Excel books and we'll start doing it. All right, so do you want to do it on your own or want me to do and share the screen? Guys, how you want to do it?
Nayan, it would be good if you can share your screen
You
and
have
show us how
sent.
to calculate. I'm little bit
Yeah.
stuck here.
Okay. Okay, so my screen is visible to everyone. I'm
Yes.
glad that people have already started to put answer in the chat box. Great, you will find out whether you're correct or not shortly. All right, so the first thing, let's see what things we have. Okay, so let me get back to that screen. Okay, so we have got mean as 35.5. We have standard deviation as 0.9, and we have specs as 35 plus minus 3. Okay, now let me paste the formula of CP here so we can easily do it. Okay. So this is the formula of CP. Now, for calculating CP, what is the thing we require first? It is the USL. Now tell me, what is going to be the USL in this case, upper specification limit?
34.7.
34.7. Why USL is going to be 34.7? How did you
Because
calculate?
because of 35 minus 3.
So I am asking about upper specification limit. So upper
Yes.
specification limit will be 35
38.
plus 3.
38.
Okay?
38.
Yes. Yes. Now, the next thing we require is the LSL. So let's see what is going to be the LSL. It is going to be
32.
35 minus 3. So 32. So now we have got the uh, first two things that we require for this calculation. Now let's see what is going to be the 6. Okay, so what is the standard deviation here we have? It is 0.9. So what is going to be the value of 6 sigma here? 6 into 0.9. Okay, are you with me till here?
Yes, Nan.
All right. Now let's calculate USL minus LSL right away. So we have 38 minus 32. So CP will be equals to USL minus LSL is 6. So 6 divided by 5.4, it is 1.11. Any questions? Was it easy? So many
Yeah.
of you have already given the right answer. Wonderful. Okay. So CP calculation is very easy. Nothing to worry about. The next thing we are going to do is calculating CPK. So let me quickly paste the CPK formula also there for you. All right. Now, for calculating CPK formula, what is the thing we require first? Now let's forget this. We have already calculated this. Let's focus on CPK. So we are going to take the minimum value of these both. So the first thing we require is X bar, right? What is X bar here?
Mean.
Mean, right? So the mean here is 35.5. Now we already have LSL and USL, so I'm not going to write it again, but we will need 3 sigma value here. So what is going to be the 3 sigma value here? Anyone? What is going to be the value of 3 sigma?
3 into standard deviation.
0.9. Great. So 3 into 0.9 is going to be our second value. So to calculate this, the first one, which is X bar minus LSL. what we are going to do? What is our X bar? 35.5 minus LSL is 32. All right. So the 3.5 divided by our 3 sigma value, which is 3.09. So one of the values is this.
And
CPK
3
for
sigma
the
is wrong, Mano. 3 sigma is 3.09. How it is?
so we did three did I some calculation mistake?
2.7.
2.7.
3 into 0.9.
All right, 2.7. Okay, so this is our value for the first part. Now let's calculate it for another part, which will be X bar, USL minus X bar. So what it is going to be? What is our USL here? 38 minus X bar is 35.5. Right? So what is going to be the other value? 2.5 divided by 3 sigma value, which is 2.7. So this is second value. So which one of this is going to be our CPK? We calculated two CPKs. One is 1.29 and another is 0.92. So which one of these is going to be our CPK value?
0.925.
92.92.
Why? Because this is the minimum value of
Minimum
these both, right? From 1.29, 0.92. 0.92 is the lower one, and we have to look at the minimum value. So we'll be taking 0.92. Now, understand why this process will be not capable. Why? See, we have got the CP value, which is 1.11. And technically, the CP value should be more than 1. So it is 1.11, right? But the CPK is 0.92. And we understood this, that CP and CPK both needs to be 1 or more than 1 in order for a process to be capable. So that is why this process will be termed as not capable, because the CPK value here is 0.92, which is less than 1. Okay? Fine. Now, please explain 35.5 X bar. What explanation is required in it? That 35.5 X bar is the mean, which is already there in the question. Wait, let me share the screen once more. So 35.5, which is X bar, is the mean which is already there in the question. Okay. So I have not calculated anything new there. Okay. Now I'm going to give you an exercise. So in just how we calculated mean and just how we calculate CP and CPK, you will be calculating CP and CPK for this set of data. Here the mean is 60, standard deviation is 1.9. I've already calculated USL and LSL for you, so it is 48 and 72. Now find CP and CPK for this, and you will not just have to submit answers in chat box, but you'll have to share your Excel file so I can see how you have calculated it and not use ChatGPT. So for this exercise, giving you 10 minutes. So we are starting at 8:54. So 9:04, I'll ask for answers. So just don't give answers in the chat box in one word. You will have to share Excel sheets on which you have done the working. Any questions? The question is clear to everyone, right?
Yes, Nan.
All right. Yes.
Then while calculating CPK, I'm getting the same value for LSL and USL. I mean, when I you know uh, deduct I mean when I do mean minus LSL, I'm getting the same value, and when I do USL minus mean, I'm getting the same value.
Yeah, it is okay, no problem.
Okay.
So see, many of you have already shared the answers here. Shanti Ranjan, I would like to see what and how you have calculated, and that is why I'm asking for the Excel file, but it is okay, and your answers are correct. Abhishek, yours are also correct. And Deepika has emailed me, so I will check it shortly. And wonderful, Karthik, you did it in such short time, and answers are also correct. All right, so do you want me to walk you through this exercise once again, or should we move to the next?
Mayan, can you see my screen?
Can I what?
I have shared the Excel sheet.
Oh, all right, okay. All right, guys. So let's do this question once again. I will share my Excel sheet and let's see. Okay. So let's use this Excel again. I'll erase the values. All right. So what is the mean that we have here? It is 60. What is the standard deviation we have here is 1.9. What are the specs? So we have already got LSL in USL, so we don't need it. We will quickly go to USL is 72, LSL is 48. What is going to be USL minus LSL? It is going to be 72 minus 48. What is going to be our 6 sigma here? 6 into 1.9. Okay, wait, I erased that CP wala formula. Let me get it back. Okay, so what is our CP formula? USL minus LSL divided by 6 sigma. So it is 24 divided by 11.4. So it is coming as 2.1052, which is same as your answers. So now you know that you have answered it correctly. Next, what is the X bar again here? 60. What is 3 sigma value? 3 into, what is the sigma value? 1.9. So 3 into 1.9. Now what is X bar minus LSL here? So X bar is 60 minus LSL is 48. Okay. What is USL minus X bar? So USL is 72 minus X bar is 60. So what is going to be value here? It is going to be this divided by this. So either we take this value or we take 12 divided by 3 sigma, which is 5.7. So in this case, both are now CP, CPK. Both are more than 2 and are equal, which means that this process is highly capable and also centered. Okay?
Nayan, I have one question.
Yes.
It could be a little bit off the topic because right now we are in control phase, but what is the major difference between PP and PPK and CP and CPK, and in which situation do we use them?
So we currently only started with CP and CPK. We have not covered PP and PPK. I'll explain you what is the difference between both when we reach at that topic.
Okay, no problem.
Or all right. So I think now we can easily calculate CP and CPK. Let's move.
One more thing, Nayan. Actually, one
Yeah.
question. So you correct me if I'm wrong, because as far as I've understood that calculating process capability whether it should be part of measure phase or control phase, because we cannot, I mean, execute analyze phase until we know where our current process is running. So, I mean, please add if I'm wrong here.
See, when we started the control phase, I explained that control phase is there to see that from this you can understand the basic difference between the specification limits and the control limits. So specification limits comes into play, which are given to us by the customer, which is collected using the voice of customer, and that we do in analyze phase, in improvement phase, and starting from define only we start working on it. But when we are in control phase, we work on control limits which are told to us by the process. So once you have improved the process, you will get to know what is the control limit. So you have already improved your process, you have already made it better, and now you're working on control charts and CP and CPKs. So that is why control charts, CP and CPKs only comes into action into control charts, into control phase. Sorry.
No, I think I couldn't frame my question. My apologies. I wanted to ask because before we initiate analyze phase, right? Because in analyze phase, what we do hypothesis testing and prepare the action plan and FMEA and all that thing, right?
Correct.
Now,
Correct.
before we execute the analyze phase, I mean, and a professional should assess where the current process stands, which is the current process capability we have right now, so that we can understand on which sigma value are currently we are running, and then we can improve. So, I am pretty sure that it is something I'm missing a piece of it. But I mean, calculating process capability, should it be only part of control phase, or it should be calculated, I mean, while you finishing a measure phase as well after doing the
Okay.
MSA?
Tell me one thing. Um, what is the agenda of doing Lean Six Sigma on any project?
Agenda is that we first of all identify the problem, right? We
No,
understand
that
what the
is not
problem. Yeah,
agenda. No, no,
yeah,
no. Let
yeah.
me question again. What is
Hmm.
the agenda? Why we are doing Lean Six Sigma on any project or process?
To reduce the defects and reduce the
Yes,
variation.
yes, yes, correct, correct. So, if you have already selected a project because you want to reduce the variation, make it more lean, make it defect free. So, you
Mm-hmm.
already know that process has got some defect. So, if see, there are two things you can do here. If
Mm-hmm.
you want to perform control phase, use control phase tools in finding out where your current process is, you can do
Mm-hmm.
that also. But
Okay.
the essence of these tools are to make sure that your process continues to be the way it is after the improvement phase.
Okay. Makes sense. It means we can do it both ways, right? Okay.
Yeah, if you want to.
Yeah, makes sense. Thank you. Thank you for
All
clarifying.
right, welcome. Okay, everyone. So let's get back to topic. All right, so here is one more activity that I want you to do. Same CP calculation and CPK calculation. Here you're producing cookies. Each cookie should weigh 20 grams. The acceptable weight range is 19.5 to 20.5. All right. We collected weight of 10 cookies and produced in one batch. So data is this. Now your task is to calculate CP and CPK and tell me what are your results. Any questions? Is the question clear to everyone? Earlier I was giving you ekdam bana banaya khana ki this is mean, this is standard deviation. Now I given you a problem because I want you to understand how you can get those terms from general language. Okay, so I'm giving you 10 minutes for this. We are at 9:10 and I think, yeah, so 9:20, I want answers.
Hello. Hello.
Yes, yes, yes.
Then I will share it.
Yes, yes, I'm on it. Just give me 1 minute. Let me see. Your CP is correct, but CPK there is some variation coming. So let me check what you have done here. Is P1 minus P3 divided by correct. And what have you done here? P4 minus P1 divided by 5. Yes, correct. I forgot to note when I started the time. So I think we started 9:10, right? We started at 9:10. So guys, only 3 minutes left. If anyone is having any question, please let me know. I will help you. Janila, no, it is not. Please check the formulas again. I think you are making some mistake in selecting the cell values.
Nine standard deviation is taken as 0.5.
You
I
have
have
taken,
as 0.5. Maybe there is where I'm wrong, I think.
let me see what is the standard. Okay, so just go through the question once again and you will understand which value you should take.
Okay, got it.
Yeah. Only Shanti Ranjan has shared the file yet. So, what if anyone can share? Are you guys facing any issue, or you just want more time? Anyone? If you need time, I can give you 5 more minutes. But if you have any questions, please let me know. All right. So Seema has shared the file. Wonderful. Let's see what she has done.
Is it correct, Nayan?
Just 1 second. I'm just checking. Give me 1 minute. Yes, Seema, it is correct. Perfect.
Nayan, I want to know means CP and CPK comparison means which process is uh, it's
Yes.
excellent. So that
Once,
comparison still it is not clear for me. So just
yeah.
you break
So
that.
you're asking about PP and PPK.
No, CP and CPK means you told that when it is same and when it is greater than 2, that I still not getting properly understand.
Okay, don't worry. I will
Yeah,
share that photo on the group. So
yeah. So I will.
yes, yes, because that is something which really helps. All right, so I'm pasting that in the chat here, so it will be easy for you to remember and refer to. All right, so I think now you are pretty much confident on how we can get the CP and CPK calculation done.
Hi, ma'am.
So I will also share the correct answer here so you can match your answers. And it is okay, maybe because of point or decimal values, or there could be a slight difference, but not much. So the correct answer is in your chat box. All right, so let's move
Madam,
ahead.
excuse me, ma'am. Please,
Yes,
ma'am.
yes.
Ma'am, please, SD I cannot calculate, madam. SD. All formulas are okay, no issue. SD is how much? 0.26, how it is?
Okay, let me check what is SD. SD. It was 0.26.
Yeah, how it is calculated, madam? I think for me it is 0.5. How it is 0.26? Please explain 1 second.
So you just have to use simple standard deviation formula in the Excel sheet. Just go is equals to STD and select the second one and then select the whole range you're working on.
Please share my screen though. Share the screen, ma'am.
I have not done this exercise. It was for you only. So I'll have to do the whole exercise again.
No, madam, only SD.
Yeah, for SD also. Okay, just give me a minute. I'll share once. Wait. Let me note down the numbers also because I was not doing it. Okay, so these are the data points that you have, right? 19.6,
Yeah.
20.1,
It is okay. It is,
19.
we got mean.
Yes.
Okay.
Yes. So just is equals to STD and select the second one, press tab, and then select the whole range from here to here, and then bracket close. So standard deviation will be 0.26013. Okay.
Including mean.
No, why will you include mean here? It is only for the data points. No, not including mean.
Okay.
Okay.
Okay,
Yeah.
madam.
Okay. Now we'll quickly move to the, or so it's already 9:26. So let's take our 15 minutes break and then we'll move to the next topic. Anyone is having any question?
Yeah, Nayan, regarding the CPK values, so why there is decimal levels even difference? You have calculated it is 0.63 and mine was 0.51.
0.51. So there must be some mistake that either in calculation of standard deviation or something, because 6463 is somewhat relatable. 51 is very far. So I'll check your sheet again. I think some mistake you have done in that calculation. I'll check in the break and I'll let you know. All right, everyone back from the break. Let's start, okay? All right, so we have already done the CP and CPK. Now we'll understand PP and PPK. I'll say not very huge difference, but also very huge difference. So the calculation and things are very same. So we don't have difference in that area, but the purpose for it, for which PP and PPK are used, are very different. So
Nayan, I want to interrupt, but the earlier exercise which we have did, in that the process is capable or not, because it's less than 0.7, so there is an improvement charge.
yes, yes, it
No,
is not
that
capable. The process is not
okay.
capable. And
Capable,
also, yes, also, Shanti Ranjan, I think I was looking at your sheet. So just go through your sheet once. So the mean which you have calculated is different, and the mean which you have manually put in the B1 is different. Very slight difference, but it changed the whole picture for you. So just go and correct that, and your whole answer will match our answer.
Okay.
Thank you.
Thank you. Thank you. All right, so where were we? We were on PP and PPK. Let me close these sheets once. Okay. Okay, so we have done this activity. Let's move to the next part. All right. So till now we have spoken about CP and CPK, that they measure the potential capability of a process in the short term, because we have been working on the sample sizes, on the subgroups. Now let's move to PP and PPK. Now, which tells us how the process actually performs in the long term. Okay, till now we have been taking samples like for shifts, for particular operators, or maybe days. But now we'll be talking about the whole process in the long run. Now, PP stands for, wait, let me release a pointer. Okay. So the PP stands for Process Performance Index. So it looks at the overall variation in the data and not just the short-term subgroup variation. So the formula goes like PP is equals to upper specification limit minus lower specification limit divided by 6 times the deviation, which is overall, not just for the process. So here the sigma standard deviation is overall, okay, not like one we were doing in CP. So PP answers the questions like, how does my process perform when I include all the shifts, all the operators, and all the real world variations in it? All right. Now let's go to PPK. See, the calculation is going to be same just like we did in CP. So we are not going to do any activity again for it, because the formula is clear. We have already done it. So you guys will be able to do it. So let's go to PPK. Now, PPK stands for Process Performance Capability Index. All right. So just like CPK, it checks whether the process is centered or not. So the formula is same, minimum of USL minus X bar or mu minus LSL divided by 3 times of the standard deviation, but overall. All right. So PPK tells us not only how much variation exists, but also whether my process is shifted towards one side of any of the specifications. Okay. Now let's understand what are the key differences between CPK and PPK. So let's start first of all with CP and CPK use within the subgroup standard deviation. So what it tells that short-term view and potential capability. But PP and PPK tells us about the overall standard deviation, which gives us long-term view plus actual performance. Right now, think of it like either of them, CP or CPK, are like snapshot of the capability under the controlled condition. Whereas PPPPK is like a full movie of performance, right? Across the time, the full movie across the time. Now, if PP and PPK are close to CP and CPK, what does it mean? That the process is stable and it is also consistent over time, right? If PP and PPK are much lower, it means that the process is unstable and there are chances that more variation will creep in over the long run. So that is the major difference between CP, CPK and PP, PPK. Okay.
How this sigma overall can be calculated?
Same process, just the data will be different. Same process.
And the mean is overall mean in this, no?
Yes,
PPK.
yes.
Okay. Thank you.
Everything we'll calculate here will be overall. All right. Now we'll walk through a foundational tool in quality control, which is the type of data we already did it once. I'm going to run through this again. So this so it clarifies several important concepts also, such as defects, what is defect, what is defective, right? What is continuous, what is discrete. So we have already covered continuous, discrete in the define phase, but let's run through this again. Okay. So quality control in any industry relies on the careful collection and analysis of data. And we have learned this thing अच्छे से अभी तक में. The type of data collected determines not only how we monitor our process, but also tells us that which statistical tool or control chart should be used to maintain and improve our quality. It could be product quality, it could be service quality, it could be anything. Now, looking at this table, basically the flow chart, the main division is at the very top, which is the selection of the control chart. Now, this gets split into two parts, which is continuous data and discrete data, and we already know what is that. So now, the one which can be counted is also known as attribute data, which can be classified, and the one which needs to be measured is also called as variable data. Now, so attribute data is countable and classifiable. So let's start with the count or classification, which is also called as attribute data. So there's often confusion between terms like count, classification, defect, defectives, like, so let's clarify these things first. Now, what is defect? So a defect is any single instance where a product does not meet the specified requirements, right? So there can be multiple defects on a single product. For example, if a mug has a chip and a crack, those are the two defects. Even though there is only one mug, but how many defects that mug has is two. Now, what is defective? A defective item is a product that has one or more defect, making it unacceptable for use. So in our case, our mug is a defective product, but it has got two defects. All right. So while an item can have many defects, it is only counted as one defective. So if it fails the quality criteria, we are going to count it as one defect. Now, what is count? Count refers specifically to tallying these individual defects, regardless of how many items are being inspected or if multiple defects appear on the same item, doesn't matter. So, for instance, inspecting, let's say 100 shirts. So you found that 100 shirts might reveal that there are 15 stains on them, there are 10 tears on them. So for a total, we have 25 defects. Now, when you use counts of defects, you are often asked, how many problems did we find in total? Right? Then comes the defectives, which is also classification. So classification means grouping each item as either defective or non-defective. Here. So here the focus is not on counting each individual flaw, but on whether or not that item is acceptable. Right? So continuing the shirt example, if 10 shirts each have at least one defect, so we classify those 10 shirts as defective regardless of how many defects each shirt has. All right. Then we have the variable data, which comes under the measurement. So this type of data represents actual measurable values like length of the shirt, weight of anything, thickness of anything, right? So when monitoring with variables data, the tool focuses on the process average and variability. We know this by now. So using control charts that are tailored to data and sample sizes is very important, because by that we can understand which tool we require, which tool is needed there, right? Now, let's understand what is fixed sample size and what is variable sample size. So now this is a very essential concept in the use for control charts, which we are going to cover later on, whether the sample size is fixed or variable. So what is fixed sample size? Fixed sample size means that for every inspection or sample, you always check the same number of units. The number of units that you're checking are fixed. For example, always inspecting 50 widgets at a time. This consistency makes calculation and interpretation easier, and since the expected variation stays the same throughout the process, right? Now let's understand what is the variable. Okay, now, so as the name suggests, variable sample size, right? However, means the number of items you inspect change from sample to sample. Now, you might inspect 40 widgets one day, 60 another, and so on. So, variable sample sizes require special adjustments when analyzing the results, right? So, as the it could be amount of data, because there is always going to be the expected variation, because the sample size is also varying. Now, so let's go through the control chart overview once. So what we are going to do is tie these concepts back to the control chart selection in the flow chart that is on your screen. So for count of defects with a fixed sample size, we are going to use a C chart here. For count of defect with variable sample size, we are going to use a U chart. For classification of defectives with a fixed sample, where the sample size is fixed, what we are going to use? We are going to use a NP chart. For classification of defective with variable sample size, we are going to use a T chart. Now, let's come to the subgroup size, the measurement part. Now, if the subgroup size is not 0, 1, which is individual single, then we are going to use IMR chart. It is XMR, but I think some mistake. So it is IMR chart. If it is from 2 to 9, then we are going to use X bar R chart. If it is from more than 10, somewhere more than 9 or 10, then we are going to use X bar S chart. So do you want to do an exercise for this, or shall I? What is the time? It's 10 already. Wait. Okay, let's not do an exercise. I'll give you an example so it is more clear to you. Suppose there is a bag manufacturer and it inspects 100 bags each day for, let's say, loose threads, chain issues, or tears. Now, if the focus is on number of the flaws, which is the defects, a C chart or U chart is appropriate depending on whether 100 bags are checked every day, like if the sample is fixed or the number is fluctuating, if it is variable sample. Now, if the focus is on total number of rejected bags, which is the defectives, regardless of how many separate flaws each bag has, then NP or P chart will be used depending on the size. Now, the difference between defect and defective, that defects are individual flaws, defectives are rejected items. So count pertains to how many defects appear, while classification focus on how many items are unacceptable. All right. So knowing if your process uses a fixed or variable sample size ensures that you are using the correct statistical tool. So basically, this table is more than a flow chart. It is actually a complete roadmap to selecting the right chart. So understanding your process variation, driving continuous quality improvement is very important. So by having a clear grasp of these definitions, these terms, and how you can apply them, you'll be able to gather more meaningful data and make, let's say, smarter decisions and support your quality goals of your organization. So if you want, you can also take screenshot of this because this might be a question when we move towards the control charts, that we have learned so many control charts, but we are not getting how to use them. So that is the purpose. I put this slide before because to avoid confusion, it is very important you understand which chart should be used when and where. Okay. Now we are starting with a very powerful concept in the SPC, which is statistical process control. So variable control charts. So by the end of this particular topic, you will not only understand what variable control charts are, but you'll also know when and how you can use them and why they are so critical for maintaining quality in the processes. So let's begin. Okay, let's go through this again. So variable is something that can be measured on a continuous scale. Like I gave you example of weight, length, time, let's say temperature, pressure. All right. So when we talk about variable control charts, we are focusing on monitoring the continuous data. Okay. So however, in attribute data, we were doing things like pass, fail, defective counts. Here we are more focused on the continuous data. So variable control charts basically allows us to track whether our process output is staying stable and consistent. Okay. So it is showing signs of abnormal variation if it is there in your process. All right. Now, let's understand why do we even need these charts? Okay. So, let's again take the example of our biscuit factory. Imagine you're baking biscuits in the factory. Each biscuit should weigh 20 grams. If one biscuit is 19.8 gram and another biscuit is 20.2 gram, is that okay? Probably yes. But what if one biscuit suddenly comes out to be of 22 grams? So control chart helps us answer these questions. So they tell us, is the variation just common cause, which is natural and acceptable, or is it special cause? So something unusual that needs to be investigated. So without such charts, we will be just doing guesswork. So with charts, it is important that you understand that which charts you will be making decisions which are also data driven. Okay. So there are several types of variable control charts, but these are the three main ones which we'll be covering. First one is X bar R chart, second is X bar S chart, and the last one is IMR chart. So X bar R chart is used when the subgroup size is very small, let's say 2 to 9. Then X bar S chart is used when subgroup size is larger, typically 10, 9 or more than that. However, with IMR chart, which is individual and moving range chart, the full form of IMR is individual and moving rate. And in the R, this in X bar R, this R stands for range, and in X bar S chart, this S stands for standard deviation. So IMR chart, which is individual and moving range chart, is used when you don't have subgroups. So you only have just one single data point at a time. So we'll go into each one of these with examples. All right. So let's start with the most commonly used, which is the X bar R chart. So the X bar chart shows the average value of each subgroup. Okay. The R chart shows the range. The difference between the, now what is range? We have already covered range. Can anyone tell me what is range? We have already covered it when we were doing the median and mode. What is range, guys? Anyone who remembers what is range?
LSL, USL.
Sorry, someone said something.
LSL, USL, that is the range.
So basically, the difference between the highest and lowest value in the subgroup is called as range. All right. Not together, the X bar chart and the R chart together, they help us see if the process average and the process variation are both in control or not. Because remember, I told you that sometimes means lie, right? So to make sure that mean in your process is not lying and it is reliable, we always look at the X bar chart along with the R chart, which is the range chart. Okay, let's take an example. Suppose we take 5 bottles, let's say of soft drink. So every hour we are taking and measuring their volume. The X bar chart will show us the average volume of those 5 bottles. The R chart will show us how much difference there is between the smallest and the largest bottle in that particular subgroup, in the data covered in that particular hour. All right. Okay. This is the simple formula. So for the average chart, for the range chart. Now what the central line. So what is the central lines here? It is the X double bar, which is average of the subgroup averages. Okay. What is the UCL here? It is X double bar plus A2 plus R bar. Now, what is R here? R bar is the average of the subgroup range values. A2 is a constant which for which we can take value from here. So if you're working for a subgroup which has got for 5, so you can see 5 of A2, it is 0.58. So value of A2 here will be 0.58. Now if let's say it is 9, so A2's value for 9 subgroup will be 0.34. All right. Next, we have UCL, which we already know it is upper control limit. It is LCL, which is already, you know, it is lower control limit. All right, now let's go back to your Excel sheets and do this exercise. Let me stop the screen share once. All right, so please open the sheet that I'm sending to you on your Excel files because I want you guys to do this along with me so you get better picture. Otherwise, I'll just keep on doing and you will go haywire. Okay. All right, so I have shared one Excel file with you in the chat box, which has got some sample points. Please open it and let me know once you're ready. Ready, everyone? You got the file, opened it in your system? All right. Now, I'm not going to share my screen because otherwise you will not do it along with me. If there are any questions, let me know. I'll walk through that step again, but I'm not going to share my screen here purposefully. All right. So let's open your sheets. The first thing that you are going to do is put this on your Excel sheet. So put this photo, the image of what points we want to calculate, what are the terms that we need to calculate. So it is on your screen and you know how to calculate. Okay. So the first thing we require is X double bar. Now, to get the X double bar, first we need to calculate the X bar. Now, what is X bar? So simply go to G5 and take average of that subgroup. So you will just type is equals to average and select the range from B5 to F5. So you will get your first average of that sample one subgroup. If you have done, please type in the chat box what is the value you have received in the cell G5. Let me repeat it again. The first thing that we need as per the formula is X double bar. And to calculate X double bar, we need X bar first. So for calculating X bar, simply go to the cell number G5 and take average of the first subgroup, which is from B5 to F5. So in cell G5, simply type average and select the range from B5 to F5. Yes, correct. So you will get 0.12478. Now, do the same till G19. Do the same process which you did in G5 till G19. So for all the subgroups, you will have the X bar. Tell me what is the value you got in G11. You can simply drag it or copy paste. Tell me what is the value you got in G11. Yes, Shriram, perfect. It is 0.12406. All right, great. Now tell me what is the value you got in G18. This is just to make sure that you are not making any calculative mistakes here. Yes, 0.12488. Wonderful. So you have successfully done the first step of this calculation. Now let's move to the next column, which is, okay, so let's look at our formula first. So what we want next is X double bar. Now to get X double bar, what you can do is select, go on any column beneath the table. Let's say in A21, you write X2 bar. So X2 bar means X double bar. So in column A21, write X2 bar. And now in B21, we are going to calculate X double one. So how you are going to calculate? Simply type average and take average of G5 till G19. What is X double bar? That you are calculating double average of the X bar. So you have got the average of this whole data point. Now what you'll do is calculate average of that average. So simply type in B21 average and select the range from G5 to G19. What is the value that you have got there? 0.12. Wonderful. Correct. So you are with me till here. Great. Now, what is the next thing we require here? It is the A2. So what we want? A2. And how many observations we have? We have 5. So find out the, wait, let me share that here. All right, I have given the image in the chat box. Now take the value of A2 where the value of n is 5. So see where A2 and 5 are colliding. Tell me what is the value where A2 and 5 are colliding? What is going to be the value of a A2? .58. Perfect. All right. So write down next to the that value. So let's say you are taking A24. In A24, mention A2, and in B24, mention the value of your A2, which is 0.58. So now, if you look at the formula, you have got X double bar, you have got A2. So now you want the value of R bar. So come back again to the table. Now, in the column H and cell number H5, what we are going to calculate? We are going to calculate range for these subgroups. So what we are going to do? That from B5 to F5, we need the range. So maximum between B5 to F5 minus minimum in B5 to F5. So very simple formula we can use for this. No need to do it manually. Simply type equals to max, M-A-X, and select the range from B5 to F5. Now type minus and write min, short form of minimum, min, M-I-N, and again select the range from B5 to F5. Tell me what is the value that you have got? 0.0032. Let me see. Yes,
Hello,
correct. It is.
Nayan,
Yes.
can you repeat because my Excel was not getting calculate properly. So can you
Okay.
repeat from A2 because I'm just
Okay. So you got the value of A2. How we calculated the value of A2?
no, I
No.
have just calculated the X double bar
All right.
and
Okay.
after that,
So
okay.
simple. I have given the image in the chat box, which is the reference table. So A2 is a constant and we can get its value from here. So if you can see in the image, how many observations we have? We have 5 observations, right? We are doing it for 5 subgroups. So we have 5 subgroups here. So the value of n is 5 and we want value of A2. So just see in the image where A2 and 5 are colliding. So there you will see the colliding point is 0.58. So the value of A2 is 0.58. So you can note it down on the Excel sheet anywhere. So I have noted it on A24. I have written A2 and in B24 I have written the value which is 0.58. Okay. So now if you look at the formula, we have got X double bar, we have got the value of A2, and the next thing we require is the value of R bar. So R is basically the range. So for calculating range, we'll come back again to our table and in just next to where we calculated X bar, we'll calculate R for this. Now in H5, just what you have to do for calculating range, simply the maximum in this value minus the minimum. So type is equals to max, which is MAX, and select the range from B5 to F5. Then type minus and MIN, which is short form of minimum. So MIN, and then again select the same range from B5 to F5 and then just simply type enter. Now tell me what is the value you got in H5. Yes, correct. So the value you guys have received is correct. It is 0.0032. Now, very simple step. Simply do this till H19. Now, tell me what is the value you have got in H12. H12. 0.0023. Correct. Perfect. Now, tell me what is the value you have got in H14. H14. What is the value in H14? It is 0.0031. Perfect. Now tell me last value for H18. What is the value in H18? 0.0. Good. Perfect. So we are on same ground. Now, the next thing we need is calculating R bar. We have got R. Now we have to calculate R bar. Now, so in A21, I have written X2 bar. So I'm going to write R bar just right below it. So in A22, I have written R bar. In B22, I am going to calculate the value of R bar. So what does R bar means? The average of the range that we have derived. So simply is equals to average and select the range from H5 to H19. Zero point zero zero two seven two. Wonderful. Great. Perfect. Okay. Now, a very simple thing that we are going to do is, one second. All right, so now we have got the value of x bar also, you have got the value of x double bar also, and you have got the value of r bar also. Okay, now let's go to the range chart. So I am giving you the image of range chart here. Now copy this and put it next to that chart where we were working. Okay, so now for the range chart, what are the things that we want? We already have R bar. We want to have a UCL, which is D4 into R, and we want LCL, which is D3 into R bar. Okay. Now, before that, we have done all the calculation, but we have not calculated the UCL X bar. Okay, so go back to the sheet and let's calculate what is UCL for the X bar chart. So if you will refer to the first image which I have shown to you, what is the formula of UCL in the X bar chart? It is X double bar plus A2 into R bar. Very simple, and I have full trust in you that you guys are going to give me correct answer for this. 1, 2, wonderful. Yes, so the value of UCL X bar is 0.126271. All right, so everyone with us, you are able to do this, right? If anyone has got any question or wants me to slow down, please let me know. All right, so far the answers that I have received are correct. Now let's calculate LCL X bar. What is LCL X bar? It is X double bar minus A2 into R bar. So simply, what is the value of our X double bar? Minus, what is the value we derived for A2 into the R bar? Yes, Deepika, correct. Value is 0.123116. Great. So now you know how to do the calculation for the X bar chart. Now, let's quickly come to the R bar chart. Sorry, the R chart. All right. So for the range chart, what are the things we need? For the center line, we want R bar. For the UCL, we want D4. We already have R bar. And for LCL, we want D3. We already have R bar. So for calculating R bar, okay, so we already have R bar. It is 0.00272. Now, what is going to be the value of D4 here? We have already derived the value of A2 from that image, from that reference table. Can anyone tell me what is going to be the value of D4 here? 2.11. Correct, correct. What is going to be the value of D3 here? No, for D3. Correct. D3's value is going to be 0 because when we see the colliding point between D3 where the value of N is 5 is 0, and for D4 the value where it is colliding to 5 is 2.11. Correct. So now okay, so I have reached till in A29, I have written D3 and in front of it, I have kept the value as 0. In A30, I have written D4 and its value is 2.11. Okay. Now, let's leave one line. And now we are going to calculate UCL for the range chart. Now you see the difference between the control limits and specification limits. Did we have we done any sort of calculation when we were trying to understand about specification limits? We use specification limits so many times, but we never did such in-depth calculation for getting specification limit. Why? Because we were collecting it from the voice of customer. But here in control limit, it is how the process is performing, and we are calculating it from the existing data, right? Okay, so now let's calculate UCL for the R range chart. So what is the formula of UCL? It is D4 into R bar. So quickly tell me what is your answer for UCL? It is 0.005739. Perfect. What is LCLR? So LCLR, the formula is D3 into R bar. 0. Correct. Wonderful. All right. So now let's see how you can make this chart. I think for this, I will have to wait. I think now I'll have to share my screen. Hmm. Okay, sharing the screen. I have made it a little presentable. Okay, my screen is visible to everyone. Great. So I have done all the calculation. This is the first step with it. This is the second step with it. You can also go here for the second step. This can also be the third step, and this can also be the fourth step. Now, what simple thing I have done here is, see, you can easily calculate these charts from other statistical tools like Minitab and so on. But it is important that you understand how these things work before you switch to the ready to use mode, because I think roots are very important when it comes to such complex process. All right. So what we did, a simple thing here, we are going to prepare a control chart, the X bar R chart, using simple Excel bar graphs. All right. So what I did here is I have copied and pasted this UCL X bar here. This value which we created, I have just simply copied and pasted it for all the subgroups. And similarly, I have done for the LCL X bar also and for the X2 bar also. Now you will, let's say we want to put it here. So go to the insert tab. If you want, you can do it along with me as well. Simply go to the insert tab. go to the chart section. In the 2D lines, you will see this kind of chart, which is lined with markers, right? So we will have to select this. To make it easy, first we will select the data. So we are going to select these three data. Along with it, just press the control button and drag it from here to here. Okay, so your data is selected, which you will be putting in the chart. Now again, go to the chart section. In 2D lines, you can see the line with markers, and here is your beautiful chart. So this is your upper control limit, this is your lower control limit, and this is how your process is performing. Any questions? Is it clear? The purple line is your X bar chart. Okay. Are you able to do it on your systems also? Would anyone want to share it with me? Have you been able to perform it on your Excels also? Is it visible? So see, the process of calculation, it is very complex, very lengthy. So don't worry about it. You will not have to do it in your daily lives or office or processes, because you will be given access to many tabs and tools which many corporates use. But it is important that you understand how it is functioning. So all the exercise we did, you will not have to go through that daily. It is just to give you a taste of how it actually works, right? Similarly, you can do it for the rain chart also. Now go to, now what is the data that you're going to be selecting for the R chart here? Anyone? What is the data that you're going to select for the R chart? It is going to be same as the X bar chart. Do you want me to do that, or you are going to show me after you have done it in your Excel sheets? Tell me, are you able to do the R bar chart in the bar graph? Sorry, in the line chart. I keep on saying bar graph. So are you able to do the R chart? Hello, what happened? Okay, let me show it on my screen once again. Trying, all right. So let's wait for 5 minutes and let everyone sync that in, and then we'll move to the next. And if you want, I can show you the range chart also, but let's first try the X bar chart on your sheets. All right, so it is 36. Let's so Abhishek, I shared my screen, right? When share your Excel screen. Okay, so let's do it again. I will share my Excel screen once more. All right, is it visible to everyone? Okay. for making the X bar chart in Excel. Now, guys, remember you can easily do it Minitab, but you can also do it from from Excel, and Minitab is not always available, and maybe it is not available to all of you. So it is important that you understand that Minitab is not essential for making the charts. All right, so simply just select the data. The data we will be selecting is UCL X bar, LCL X bar, and X double bar. So select this data. Along with this, we will also be requiring the data of our X bar. Now, okay, so you have selected the data which you want to put in the chart. Go to Insert, go to the chart section. Here in the 2D line, you will find line with markers, and simply your X bar chart is here. You can change the name. This is your X bar chart. Okay, is it clear now? Any questions? You are able to do it in your Excel sheets also? Now let's see, the blue one here is, let's rename it. Okay, so the blue line shows the X bar, the red line shows the UCL X bar, the greenish kind of line is showing LCL X bar, and the purple line is showing the X double bar. You can rename the legends also. Were you able to do it on your Excel sheets? Can you share? Okay, Deepika has shared one image, comes like this. Let me see, what all have you written? Yes, so Tahir has shared the image of our chart as well. Wonderful. Great. Yeah, Sachin, it is okay. It's just that the markers are a little different. You can format that, no problem. All right. So those who have already done the R bar chart, okay, but those who have tried the X bar chart, please also try the R bar chart. For that, what you have to do, simply select this whole data from here to here along with the range. All right, and then put the chart. So you will get R bar chart. Let me know if you are done. So Tahir has already done, and I think his is correct too. So let's try the R bar chart also. So I am seeing positive responses from Sachin, Tahir, Deepika, Karthik, Abhishek. What about others? I hope you are also performing it side by side, because if you guys will have any questions, I can ask them right away. So let's not just wait that we are going to do it sometime else. It is okay if you're taking time, it is okay. All right, so if anyone apart from Tahir has made the range chart, please share it in the chat box so that others can also see how it is done. Very simple and just like X bar chart only. So I have done mine. Okay, so Deepika has shared. Let me see. Okay, so Karthik, you have selected, you have left one set of data. You have left the center line, the R chart, the R bar. You have left the R bar. So go to your data, go to your chart again and select that also. See, Deepika's is coming correct. Happened? Why is this coming like this? No, some problem in the data that you have selected. All right, let me share my screen for this once. Okay, so my screen is visible to everyone. So we have already done the X bar chart here. Now let's select the data for the R bar chart. So simply just select the UCLR, LCLR, and R bar. And also this. Okay. Now simply go to the tab insert. So you see what are the data that we have selected. We have selected the UCLR, the LCLR, the R bar, and the range. Now you will go to the insert tab. Here in the chart section in 2D line, you will select line with marker and simply this chart will come along. So this is your range chart. Is it clear now? So I think some of you missed to select this column and only performed it with this. So this is how your range chart will look. If you skip selecting this data, the purple line of range will not come. All right. Great. I wrongly selected X bar instead of R. All right. So this is the beauty of chart, that what data points cannot tell you, charts easily tell you. So if you will look at the X bar instead of R, you will start maybe working on it and thinking on it. But the control chart you were trying to make instantly told you that something is wrong and you need to work on it. All right. Acha, now tell me one thing. Just 1 second. Okay, can you calculate CP in the same data set that I have given to you? You have got all the things, you have got everything that is required to uh, calculate CP. Can you calculate CP in the same data set? I'm also doing it along with you. So let's try this. Do you want the formula of CP? Okay, let me just put that in the checkbox. So here is the formula of CP. Very simple. Just try to calculate CP in the same data set. So for that, what we will require? Upper specification limit, lower specification limit divided by 6 sigma. All right, so please start trying. I will be back in 1 minute or maybe 2 minutes. Oh, sorry. I thought I already, while I shared the file, I've given you the specification limit. Sorry. I just checked it. I've not given you specification limit. So let's say the upper specification limit is 0.129 and lower specification limit is 0.2. All right. I think now you'll be able to do it. How means this is already in the data that I'm giving you what is USL and LSL. It is already specified. You don't need to calculate it. Yeah. Anyone able to do it, or you're struggling with how to calculate the standard deviation here? Oh, we have got one answer. So CP is 1 point, wait, what did I mention? 1.11. Okay, Tahir, how can you explain how you calculated the CP of 1.11? If it is comfortable with you, you can share your Excel file, or if you want, you can unmute and explain it to us. None? Okay, all right. No problem. Let me tell you how to calculate the standard deviation, how to calculate CP in this case. Let me go to our file here. Wait. All right. So my screen is visible to everyone? Okay. Now, let's see. Now, for calculating, okay, wait, let me paste that CP formula here. All right, so what is the formula of CP? It is USL minus LSL divided by 6 sigma. Now, we have already got the values of USL and LSL. But how to calculate this standard deviation here? So what is the formula of standard deviation? So let's calculate standard deviation. It is simple. STD, this one. Now, what is the value that you're going to select here? So the whole data starting from here to here. Okay. So what is the standard deviation that you have got here is 0.0011. Clear? Any questions? Now, how you are going to calculate the CP? It is simple. What is USL minus LSL? This is USL minus LSL. Okay. Now, what is your 6 sigma value here? Sorry, 6 standard deviation value here? 6 into the standard deviation. So what is going to be value of CP here? This divided by this. So it is 1.211. Okay, which is greater than 1, which means that this process is capable. Do you want to try this once? Are you able to calculate it now? Got it. Okay. Anyone has any question in the calculations that we learned today? Were you able to calculate? So Abhishek, the value of USL and LSL are already given with the data. I forgot to give you when I shared the Excel sheet. It is already there. It is voice of customer. It is already mentioned in any process. So you don't have to calculate USL and LSL. You will always have to calculate the specifications of the control limit, not of the, sorry, you will have to calculate upper control limit and lower control limit, not the specification limits. So it was, I should have shared it with the data sheet only. CP is coming as 1.24. My CP is coming as 1.211. So maybe, no, even if I am working on the, okay, let me show you again. All right, my screen visible? All right, so what we did is we calculate the upper specification limit and lower specification limit already given to you. Now what we need, the next thing is this 6 standard deviation. So for this we will to calculate standard deviation. So we used a simple formula which is STDEV and not the population one. The P here stands for the entire population. So we'll not be using this. We are working on sample. That is why we will take standard deviation dot S. All right. Press tab and then select the whole data from B5 to F15 and press enter. So you will get the standard deviation as 0.0011. All right. Now, what is the next step? That you have to calculate the difference between the USL and LSL. So what is the USL here? It is 0.129 minus LSL, which is 0.121. So you got 0.008. Now, what is the value of 6 standard deviations? Very simple. 6 into the standard deviation value which we got, which is 0.0011. So this will come as 0.006601. To calculate CP, what we'll do? To calculate CP, we'll just simply divide the difference between the specification limits with the 6 standard deviation value. So this will come as 1.211. I applied the same, but my value for SD was because I selected wrong formula. All right, got it. It happens. Don't worry. All right, so I would suggest that you guys keep on practicing on how to calculate this, because that is only how you are going to get through this. And the best way to practice is just by pasting the formula on the face of your Excel sheet. So you work directly on the elements which you want to derive. All right. So that was all about today. Now, next Sunday, we are going to cover the rest of the control charts. And I know it is a lot to take in. That's why I tried not to take all the charts at once. So yes, that was all about today. Can you please share your sheet in the group? All right, I'll do that. Just one second. I'll have to save it. I hope you guys understood it. All right, so this is the file I was working on. Kindly share in WhatsApp group. Okay. So I'm not the admin there, so I cannot send that here. Please save it from here only. All right. So yeah, that was all about today. So thank you everyone. I know it was very complicated because we have been doing control charts are a little complicated to understand in first go, but trust me, you all are wonderful and you have the interaction that you have shown today is just amazing. So thank you so much. Thank you, Sachin. You too. Have a good weekend. Thank you, Tahir. Good night, Seema. Bye bye.